We have new images of Object 3 and Atlas, the third interstellar object in history. This object continues to approach the Sun, and we still know very little about it. On July 1st, 2025, NASA confirmed that a third interstellar object entered our solar system. We must check every new object that appears. But its tail was not behind it, instead pointing directly at the Sun, which contradicts all known laws of physics. Now scientists are wondering if this is even a comet. An event that struck us at a speed of 130,000 miles per hour began with a flash, just a point of light moving across the sky in observations from the Atlas Observatory in Chile. The date of this event was July 1st, 2025. At first glance, it looked like yet another icy guest from the distant corners of the solar system, but then the numbers came. Its speed was recorded at over 290,214 kilometers per hour, significantly exceeding typical comet speeds captured by the Sun's gravity. Its trajectory was almost straight, with an eccentricity of over 6, confirming its interstellar status. It was not a fragment of our solar system, but a traveler from another star. NASA published its findings just hours later. The object was officially named Tri and Atlas. This was the third interstellar object ever observed, after Oumuamua in 2017 and Borisov in 2018 to 2009. But even among these cosmic rarities, 3 and Atlas proved to be special. Its trajectory crossed the plane of the solar system, was retrograde, and almost perfectly aligned with Earth's orbit. Statistically, such alignment had less than 1 whole and 0.2% chance of occurring randomly. More experienced astronomers were in complete awe, and then images appeared that showed something truly strange and even impossible. As telescopes from around the world began to zoom in on the object, a troubling circumstance became evident. The tail of the object did not trail behind but pointed forward. An impossible tail, a torch directed at the Sun. All astronomical guides state that comet tails follow one rule: they move away from the Sun. This happens because sunlight, particularly the pressure of solar radiation, pushes dust and gas back like the wind carrying a scarf in a storm. However, 3 and Atlas refused to follow these rules. A few days after its discovery, NASA published high-quality images showing something truly strange: a bright and stable beam emerging from the sunlit side of the object and pointing directly at the Sun. At a press conference, comet science veteran Dr. Bryce Boland described it as lumpy, dubious, and directed towards the Sun. Other astronomers were more straightforward. This shouldn't happen. Various observatories confirmed the anomaly. The Gemini South Telescope in Chile and the Lowell Discovery Telescope in Arizona captured the same jet stream directed towards the Sun. It did not flicker or change, remaining stable for several days, and its shape did not match anything known in comet science. The dust seemed too heavy for the sunny wind to shift. However, it did not fall back to the core but moved forward, maintaining the shape of a narrow and focused stream. The teams of scientists conducted simulations, adjusting models to account for dust size, solar wind, and rotation speed. Nothing explained the observations. All tests failed. For centuries, comets followed the laws of physics. Halley's, Borisov's, all obeyed the Sun. This single fact made scientists consider a possibility no one wanted to speak aloud. What if this stream is not just dust, but something with intention? The chemical signs, the mystery of carbon dioxide. If the tail was strange, the chemistry was even more astonishing. In early August, NASA directed the James Webb Space Telescope to the 3I Atlas object to analyze the light reflected and emitted by the coma surrounding its icy core. What Webb discovered amazed even the most experienced comet researchers. The spectrum showed a ratio of carbon dioxide to water of 8:1. This number alone shattered all patterns. In almost all known comets, water dominates. Carbon dioxide, when it appears, is usually in the background in much smaller amounts, with ratios from 0.1 to 2. In rare cases, it reached 4, but 8 was beyond all norms, and it was not a mistake. The Very Large Telescope in Chile confirmed the data. Carbon dioxide not only dominated, but also concentrated on the same side that faced the Sun, and from which the mysterious flow originated. Moreover, an atomic form of nickel was discovered in enormous quantities, more than 10 to the 20th power atoms per second. This was an intensity rarely observed even in the brightest comets. However, surprisingly, there was no iron. This anomaly challenged the usual chemistry of the solar system, where these elements almost always occur together. The implications were profound. This object did not merely come from another star system. He probably formed in a planetary kindergarten, which was radically different, where carbon dioxide was more common than water, and nickel could evaporate without the presence of iron. But it was not only about where he came from, because if carbon dioxide was causing the jet to move, the next question was simple. What fueled it? Propulsion or sublimation? The debates are heating up. According to the theory, comets move because sunlight heats their surface, turning ice into gas. This process is called sublimation. The gas that escapes gently pushes the comet in the opposite direction. It seems simple and predictable. However, the Comet 3I Atlas broke the usual rules. Its jet, directed towards the sun, was too focused, narrow, and persistent. It did not disperse into a typical gas stream but moved in a compact column, maintaining its shape against the relentless solar wind. And then a controversial idea appeared in the discussion: propulsion. Dr. Abeloib, an astrophysicist from Harvard known for his provocative views, took the stage. He noticed that the jet resembled the exhaust from an ion engine, the same technology used by NASA to accelerate spacecraft into deep space. Ion engines do not explode like rockets. They use electric fields to expel charged particles in a narrow stream, creating a gentle yet constant push. And if you were an object arriving from interstellar space, what would you need to do? Slow down. The most effective way to do this? Direct your engines towards the sun, ignite them at perihelion, and utilize the overtone effect, a physical trick where fuel combustion at maximum speed near a gravitational well yields the greatest benefit. This is how the jet of 3I and Atlas was directed towards the sun, focused and constant. Critics claim that exotic ice compositions or the geometry of rotation could explain this phenomenon. Perhaps supervolatile substances were ejected from the surface. Perhaps the object was spinning in the right direction, but none of the sublimation models could reproduce the shape, thrust, or persistence of the jet. The scientific community was divided. Was it a natural comet behaving strangely, or something attempting to maneuver? The signature of acceleration is a gentle push. If a force, however slight, acts on an object, it must leave a trace. Not in dust, but in motion. Here, the data about the orbit became crucial. Astronomers began tracking the position of the 3 Atlas with almost obsessive attention. Observatories around the world gathered hundreds of astrometric measurements, comparing its trajectory with models that considered only gravity. Initially, the mathematical calculations matched. The object followed a clean parabolic trajectory, as expected from an interstellar body. But by mid-August, something changed. The residual values, small differences between predicted and observed positions, began to grow. They were not random. They had direction. They always directed towards the sun, precisely in line with the stream. A team from NASA's Jet Propulsion Laboratory conducted a model considering non-gravitational factors, adding a small acceleration component towards the sun. The correction improved significantly. What was the calculated force? Around 4 times 10 to the minus 7th meters per second squared. This value is tiny, like the pressure you would feel from the lightness of a feather in your hand. But over time, in space, it accumulates. And here comes the twist. This magnitude and direction closely match what an ion engine could produce. The dust in the stream was not light and dispersed. It was dense, heavy, and focused. The modeling showed that to achieve such movement, the flow must consist mainly of large particles ejected with a constant force, not chaotically, not randomly. Whether by nature or design, something was pushing the 3 Atlas, and that something did not slow its actions. Echo of Howlow, lessons from the first visitor. This is not the first time an interstellar object has puzzled scientists. In 2017, a strange object, spinning at high speed, crossed the inner part of the solar system. It was named Oumuamua, which translates from Javanese as scout. Unlike everything seen before, it had no tail, no coma, nor visible signs of degassing. Nevertheless, its trajectory showed a mysterious acceleration that could not be explained by gravity alone. Familiar, isn't it? Some suggested it could be an iceberg made of hydrogen, sublimating unnoticed. Others proposed hypotheses about exotic ice or other structural anomalies. However, the idea that Oumuamua could be an artificial object controlled by solar wind provoked both outrage and admiration. But one thing was clear: the data did not fit into familiar frameworks. Then in 2019, Borisov appeared, looking and behaving like a classic comet, restoring a sense of normalcy. Now 3I and Atlas open the door again. He has a tail, but it's pointing the wrong way. He has gas, but in incorrect proportions. And he accelerates, but in the wrong direction. The lesson from the history of Oumuamua was not that aliens are already here. It is that interstellar visitors do not follow our rules. And 3 Atlas may be the brightest example to date, a statistical anomaly, an overly precise trajectory. Most comets and asteroids coming from beyond the solar system follow chaotic and highly inclined paths, like lost arrows. But 3 and Atlas did not appear by chance. They passed through the eye of the needle. Its orbital tilt was only 5 degrees from the ecliptic, almost perfectly aligned with the plane around which Earth and other planets rotate. Such a level of alignment? Less than 0.2% chance that this happened by chance. Then came the planetary flybys. The simulations showed that 3I Atlas will pass close to Mars in October, to Venus in November, and to Jupiter in March. Not close enough to pose a danger, but close enough to raise suspicions. What is the probability that an interstellar object will fly past 3 inner planets in succession? Less than 1 in 20,000. Dynamic models tried to rule this out as coincidence, but each time researchers randomly altered the entry trajectory, they reached the same conclusion. This path is a cosmic rarity. Its almost perfect alignment, reverse motion, and sequential planetary encounters were too clean, too deliberate. This is not evidence of intent, but represents such an accurate pattern that blurs the line between randomness and design. If this object was directed towards our solar system, it didn't just aim for the sun, it chose a panoramic route, a blind spot disappearing behind the sun. Every spacecraft, every comet, every planet ultimately disappears not into space, but behind the sun. This is called solar conjunction, a period when the brightness of the sun makes observation impossible. No telescope can see through it. No radar can track beyond, and that is where the 3 Atlas probes are headed. On October 30th, 2025, this object will pass behind the sun at perihelion, at the point of closest approach. It will move at maximum speed, under the strongest influence of solar gravity. And if something happens, a course change, a sudden jolt, darkness, or bright light, we will not see it. This is not just a blind spot in the sky, it is a perfect opportunity for concealment. Orbital engineers are well acquainted with this moment. It is the time when spacecraft perform critical maneuvers to change speed using the Oberth effect. If the 3 Atlas AIs are indeed under the influence of a natural or artificial engine, it will be a moment for action. NASA and ESA teams have already scheduled rescans in case the object appears again in a few weeks. They will monitor the slightest deviations in its position, trajectory, or brightness. Until then, the object remains inaccessible, a mystery sealed behind the brightest point in the sky. And whatever it does, we will not know until it is too late or just in time. At this moment, 3 Atlas eyes are hidden behind the sun, silent and invisible, possibly in motion. When they reappear, the numbers will tell the truth. Until then, we wait, knowing that the universe has just given us a mystery that may be unnatural and possibly not singular.